zero range process. Okay, and here you have a periodic lattice, and each side has a box. Okay, and there are many boxes, and there is a periodic boundary condition, and each box has some particles, and you calculate the number of particles are Ni, and the rate at which particles go from here to here. A single particle can go from here to here with rate u of Ni. Okay, so that's what we define as a zero range process. This is our lattice, and this is what we define. Okay, and here what we find is that firstly for any u, okay, what we employ is pairwise balance to get the steady state, and we find that the steady state is actually factorized. Okay, so the steady state of this model is this P of Ni equal to product over I equal to 1 to L f of Ni and delta of summation over I Ni minus N. Okay, so that's the steady state. Of course, there is a Qn, 1 by Qn. Okay, and Qn is just sum of, right? Is and Q. Okay, let me write that. Qn is just sum of rest of the terms. Okay. So then, and we also find that Fn is a function. This is where we employ this pairwise balance. So we have pairwise balance. So this is from pairwise balance. Okay. Using pairwise balance, we find that Fn is product over k equal to 1 to n 1 by un. Okay. So that's basically the problem has this rate parameters, and we know the solution for any un. Okay. So that's where we start, and then next we find that if you take un equal to n plus 1 divided by n to the power alpha, so this is 1 plus 1 by n whole to the power alpha. Okay, in this situation we find we find that the system actually can have a condensate, and the condensate can occur at rho c critical value. So the critical value is just zeta alpha minus zeta alpha minus 1, zeta alpha minus 1 minus zeta alpha divided by zeta alpha. Okay, so basically divided by zeta alpha. Okay, so this is if alpha greater than 2 and equal to infinity if alpha less than 2. Okay, so this was hurried up little bit at the end. Okay, so I just wanted to clarify this point that why. So let us first answer this question: why 2? Okay, so the first one we will answer that why this 2 appears in many places, like in Ising model also, like you have interactions which decay faster than 1 by r square. They behave like short range interaction. Okay, so first we will try to get this answer, and this is one question. Second question is that here if we in this one Fn is this, so in the process we also calculate Fz. So your partition function, this is the probability, and the grand partition function, which I last time call G, but now I am also changing a notation called Z. It's a standard one. So Z equal to Fz, Z of, so the canonical partition function is a function of n, grand canonical partition function is a function of Z, small z. Okay, so this equal to Fz whole to the power L. That's what we find, and we also find that Fz equal to summation over n equal to 0 to infinity Fn z to the power n. Okay, and this one turns out to be 1 by z g alpha z. Okay, right? I mean that's what it turns out, and g alpha is the standard. Or somehow Ornov wrote it here. So g alpha z equal to summation over n equal to 0 to infinity z to the power n divided by n to the power. So this is, so in Bose-Einstein condensation you get g3 by 2, okay, and here you get, right, 1 by z, g 5 by 2 is related to z3 by 2. That's what I'm saying, okay. So there is a 1 by z here. So this is not exactly the same function. Fz, there is a 1 by L. So that's the point, okay. And now let us answer this question, like, why 2? Okay, and it is generally appear in many places, and you should know a little bit about this. So let us say that you think of a probability function, okay. So some probability function which asymptotically decay as a power law. Okay. So this is what you have, like, if fn equal to this, oh, I did not write one other statement. If un equal to this, given fn, so this implies, let me erase it here, this implies fn equal to 1 by n plus 1 to the power alpha, okay. So asymptotically this is 1 by n to the power alpha, right. This one, fn is just product over this. This is also I have written wrong, this is k. Actually, I'm still sleeping. No, okay. No, uk. So you have uk, k equal to 1 to n. So fn equal to 1 by n plus 1 to the power alpha. This because, you just, if you take this, everything cancels, only the last one survives. Fn, and this is asymptotically goes as 1 by n to the power alpha. So why I am talking of probability function? Because, if you say this fz is a single side partition function, right? If you go to grand canonical one, it's just a product of that, and this is just a single side partition function. So if you look at this, fn z to the power n divided by fz,